All right, welcome to example 4 in 8.2 for Math 20-1. Just another system we need to solve. It's quadratic, which makes it a little trickier, but it is set up for elimination. And the reason that I say that is that the coefficients on both y variables is -1. The one thing that I'm going to do to make this a little bit easier is I am going to move the entirety of the second equation onto the left-hand side. So I just subtracted 4 from both sides there. And now what I'm going to do is I'm going to subtract the entire equation. It's really important that each and every term is being subtracted. So we'll work through this term by term. 3x squared minus 6x squared is negative 3x squared. Negative x minus 4x is negative 5x. Negative y minus negative y is 0. And that was the intent behind this. -2, and if you're having trouble with these, write them out. -2 minus -4 is the same thing as -2 plus 4, which is +2. And that's all equal to 0, because 0 minus 0 is still 0. Now, again, the advantage of elimination is that this is no longer a system. This is just a quadratic equation, and we should be able to solve that. And the way that we do that, what I would do is immediately, I don't like that negative on my a value, so I'm going to multiply the entire equation by -1. And that's going to give me 3x squared plus 5x minus 2 is equal to 0. Now, that's a personal preference. You don't have to do that. All of our factoring techniques will still work, but I really like doing it that way. Then I would set up my t-chart. So it has to add to +5, and it has to multiply to the 3 times -2, which is -6. So two numbers that multiply to -6 and add to +5 are +6 times -1. So I'm going to rewrite the middle term, doing decomposition now with the two numbers that I selected. I do think it's very important to put that -1 there, and then I'm going to take what I can, the greatest common factor of the first two terms, which is 3x. That leaves me with x plus 2. I'm going to factor a -1 out of the last two terms, and that leaves me with an x plus 2 as well. This is still equal to 0. I missed it on that line above, sorry. What I'm going to do now is actually solve it, which is to say I am going to factor out the x plus 2, which leaves me with 3x minus 1, and that's equal to 0. Well, the only way that this is solved is if either factor is equal to 0, and that's what gives us our two solutions. This one's a little bit easier. X is equal to -2. Here I get that 3x is equal to 1, which means that x is equal to 1/3. Now, it is very important that those are only the x values. We need to determine the y values, and I am just going to use the same equation for both, which is the 3x squared minus x minus y minus 2 is equal to 0, but I'm going to move the y over. So 3x squared minus x minus 2 is equal to y, and now it's simply substitution. So the first answer is going to be 3 times -2 squared minus -2 minus 2 is equal to y. This is 12 plus 2 minus 2 is equal to y, and I get that 12 is equal to y. So one of my solutions, and I'm going to put them maybe down here, is -2 comma 12. That's one answer to this system. The other answer is found by plugging in the other x value to the same equation, and that's okay. So it's 3 times 1/3 squared minus 1/3 minus 2 is equal to y. A lot of students get a little bit worried when they see fractions like this because most students don't like working with them, but it's really important that if we take 3 and multiply it by 1/3 squared, that 3 is going to cancel one of those 1/3. So this ends up being 1/3 minus 1/3 minus 2 is equal to y. These 1/3s cancel, and I get that -2 is equal to y. So my other solution is 1/3 comma -2. So those 2 points are the solutions to this system. To verify this, as tedious as it might be, we have to take our solutions and plug them into the equations above. So the two equations were 3x squared minus x minus y minus 2 is equal to 0, and 6x squared plus 4x minus y was equal to 4. It is annoying, I know, but you have to go back and use the original equations to make sure that no little algebra mistake shows up in your verification as well. So I'm going to verify both of these, which does take a little bit of work, but it is important that you don't get this ability or, this chance to make sure that your answer is right in a lot of other classes, so exploit it. So I'll do this one first in blue. So I'm going to check in both equations. 3 times -2 squared minus -2 minus 12 minus 2 should be equal to 0. This is 12 plus 2 minus 2, minus 12 minus 2 is equal to 0, and I get that 0 is equal to 0. So that one worked, right? This 12 cancels with this 12, this 2 cancels with this negative 2, sorry, that 12 cancels with the negative 12, and we get 0 equals 0. But we have to check it in both. So we will check if 6 times negative 2 squared plus 4 times negative 2 minus 12 is equal to 4. Keep in mind that all I'm doing here is replacing x with negative 2 and y with 12, because that is what my solution indicates that we've determined. So negative 2 squared is positive 4. This is 24 minus 8 minus 12 is equal to 4. 24 minus 8 is 16. 16 minus 12 is 4. And that did verify correctly. All right, the other one, or the other, I guess, side, is what I'm going to do in black here, which is the 1/3 comma negative 2. And I really do appreciate, I know I've said it a few times, that this can feel tedious, but it is an important skill to cultivate, because you cannot always do this when solving problems. If you can verify, you should verify. Bare minimum, I would verify maybe using a graphical technique if you were doing multiple choice on an exam or something like that. So I'm going to do the same thing. I'm plugging in different values, I suppose. I'm going to put 1/3 in for x and negative 2 in for y. So is 3 times 1/3 squared minus 1/3 minus negative 2 minus 2 equal to 0? 3 times 1/3 squared is 1/3 minus 1/3 plus 2 minus 2. And we see some additive inverses happening, and I get that 0 is equal to 0. These two canceled respectively. All right, the other equation is 6 times 1/3 squared plus 4 times 1/3 minus negative 2 is equal to 4. And here's where we have to learn to love fractions. This is going to end up being 6 times 1/9 plus 4/3 plus 2 is equal to 4. 6 times 1/9, and I'm going to write this a little bit weirdly. 6 times 1/9 can be written as 3 times 2, which is 6, times 1/9. And the reason that I do that is because 3 times 1/9 is 1/3, 2 times 1/3 is 2/3. So I have 2/3 plus 4/3 plus 2 is equal to 4. Kind of ran out of room at the end here. 2/3 plus 4/3 is 6/3, and 6/3 is 2. Well, 2 plus 2 is definitely 4. So that answer verified as well. I know, again, last time in this video at least, it is tedious to verify, but it is very important because it allows us to make sure that we've done the question correctly.